Okay, good morning, buongiorno, Gabriele.
Buongiorno Tino, how are you doing?
Good, 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 good. Feel very good because it's the last webinar for the year and it's also the last working week for the year. And it was a
Okay.
very busy year. So we are looking forward for Christmas, as most of people will do now. Just looking on the people coming in. Okay. So you can see the screen now. You can see the front
Yeah, I
screen, the
can see your
start.
screen. I can see the first slide.
Okay, very good. All right. We give them a few minutes to come in. So in the meantime, they can get all prepared. And you have any plans for Christmas? You stay where you are, or you go back to Italy?
I stay where I am. I'm gonna stay in Denmark for this year, for this Christmas.
All right,
Gonna enjoy the Danish Christmas around here. Yeah.
good, good.
And do
Okay,
some work, of course. There's always something to do, so.
all right. So should we slowly start?
Yes, 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 we can start.
Okay, let me just click on this slide. All right, here we go.
Okay. Yeah, hello and welcome to everybody to this webinar about E6 61511 life cycle overview. This is one of the many topics that we cover during this kind of events, and considering the good feedback that we received so far from the participants, we continue sharing our knowledge regarding intrinsic safety and functional safety. A brief introduction about myself. I'm Gabriele Caglio. I'm a technical support specialist here at GMI, and we have Tino van de Capelle, which is the expert and today's main speaker. Next slide. I just want to introduce a bit the company for whom that doesn't know us. GMI is an Italian company, provide field interfaces related to intrinsic safety and functional safety. So this means that it's possible to find GMI devices in many industrial packages, such as DCS, ESD, fire and gas, and so on. And as you can see from the screen, we are talking about oil and gas, petrochemical, pharmaceutical, mining, but also food and beverage, and some other industries. We have over 40 years of experience in the field. The headquarters, as I said, is in Italy, where we have our main facility and where we design, produce, and test all our products. As I mentioned before, we are a safety company and we aim to provide safety and reduce the risk of hazardous event and to safeguard people, assets, infrastructure, production process, and the environment too. So for this reason, the quality aspect of our product cannot be overlooked. We design our products, we manufacture and test them 100% internally, meaning that we do not outsource any of these tasks. So this is why we are confident about the quality of our product. Couple of more slides before to get to the webinar. One is about the certificates. It's the next, I suppose. Yeah, this is the product range, but yeah, we can go to the product range in a moment. But about the certificates, we have.
Sorry, that I was too quick.
Yeah. About the certificate, or at least the certification body that we're dealing with. This guarantee the quality of our devices, but also guarantee that GMI products comply with market requirements according to different local regulation. Now we can go to our portfolio, a quick overview. Just a minute. So as I was mentioning, we have IS barriers, so intrinsically safe barriers, safety relays, SIL certified with and without light monitoring for both energized to safe or de-energized to safe application. We have isolators, we have AX power supplies up to SIL 3, temperature and digital multiplexer for Zone 1 installation. We have custom termination board for an easy connection to main PLC and DCS systems, hard multiplexer, surge arrestors, and the new X1 series, which is the new the newest line of product, which is a series of termination boards, including IS barriers, isolators, safety relays, gateways, and hard multiplexer too. The final slide is a list with some of our customers. We stretch from system vendor to EPC and EOM and so on. So, yeah, the last thing I would like to say about the webinar, this webinar is going to be recorded. So in a few days, you will find available on the YouTube channel. If you want to subscribe and get a notification, you can do that. You're welcome to do that. You will get a link to download a PDF copy of this presentation, again, in a couple of days from now. You will also get a certificate, but only if you attend at least 75% of the webinar. If you have any question during the presentation, you can write it down to the Q&A section, and we will try, or Tino will try to answer to all of them during or at the end of the webinar. And yeah, I think that's all. So Tino, please go ahead. It's your turn.
Okay.
It's your show.
Good. So we also have received some registration questions during the registration itself. I had the freedom to select those that I would like to answer. So I think I have selected 2 or 3, which were 2 of them were for me quite interesting to think about how they could be answered. Most of it will be hopefully covered during the lifecycle overview. So thank you, Gabriele, for the introduction. Today is basics. It's the 61511, and it's the reason behind the 61511, the framework, and also the life cycle. That's the topic for today. Take it back in time. I go back to 1996, where the first safety life cycle standard was being released back in USA by the organization called the ISA. And the reference for this was the 84.01, was the first life cycle quantitative approach that was released on the market. Rightly followed in 1997, we had the first edition out of the IEC 61508, and the IEC 61508 is the life cycle mainly for the manufacturers of electrical components, of electrical signals inside their subsystems, and or for programmable electronic safety related system that we will abbreviate as EEPES. So the IEC 61508 came out in 97, as I just mentioned, and the backbone of this functional safety standard was the safety life cycle, and it's based on that life cycle that we have today our 61511 life cycle, which is a similar approach and a similar framework that I would like to talk to you about. In 2004, we had the first edition out of the process industry dedicated functional safety standard. And the functional safety standard is a kind of a good engineering practice on how engineers need to define, also to integrate, to operate, and to maintain a safety instrumented systems. So the product range that Gabriele just showed you for GMI fits totally into the picture of the safety instrumentation function loops. That means that when you're building a safety loop, we will be calling that a safety instrumented function. All of that is described in that chapter 11, which is the design and engineering of your safety instrumented system. So you see here a small note or an asterisk or a between brackets. The ISA back in US that had before released in 1996 the 84.01 adopted the IEC 61511 in the year 2004 with one single change. They added an additional clause, and that clause at that time was called the grandfather clause, and the grandfather clause reference is shown over here. Moving on, we're going to 2010, and I take you back into April 2010, where the total release came of the edition 2, the revised edition of that manufacturer dedicated functional safety standard for EEPES. And the new things that were new 14 or 15 years ago now were the road to proven in use, systematic capability. And some of this was also shown on that one slide on the products from GMI, where they were showing SC3 or systematic capability 3, meaning that that product is suitable to be used in a integrity up to maximum SIL 3. In 2016, 2017, we have two different dates over here. We came up with, or the edition 2 was released by the IEC, and the IEC is standing for the International Electrotechnical Committee. So the 61511 has been revised, was released in edition 1 in 2004, but after 12 to 13 years, there was a new edition out. And the new edition is the current edition for today. Now, when the edition came out, initially 2016, there was a kind of a problem because they released a, let's say, older draft that was not supposed to be released. That is why immediately in September 2016, they came up with a corrigendum, and finally there was an amendment out in 2017. What can you take away from this story? If you are listening into that webinar here today and you are using the 61511, make sure that you are using the 2017 edition and not a 2016, which could be potentially a wrong release. There we are covering things like Road to H, which is called the prior use, where previously the 61508, the Road to H for the manufacturers, that is called proven in use. And they are both based on quality feedback data from the field that both of the parties will have to prove. Here, the preference of the 61511 edition 2 today do not want to use necessarily a safe failure fraction, and there are particular reasons for that. And Road 1H, together with the systematic capability, is still mandatory enabled to find evidence for if you are going that Road 1H selection. On top of which, the new edition 2 is also requiring a SIS security risk assessment. That's a quick summary of the changes compared to the edition number 1. And if someone were listening from the US, which I doubt, because it's here 11 o'clock in European time, so either the engineer in the US cannot sleep and will listen into the webinar, but I would doubt. But if someone of the US or projects for the US would have experience with, they have adopted the ISA 8401 that used to be called 84.00.01 is now called the ISA 61511, and they adopted the current edition to 1-to-1 in the year 2018. Of course, they wrote technical report 4 in 2020, which was the application on top of the 61511, but that's a technical report which is not shown here on this slide. Taking you a little bit into details of the standard itself, there are 3 sections. We call them section 1, section 2, and section 3. And only section 1 is a normative section. Section 2 and 3, we call that an informative section. In theory, the informative section here in part 2 should be able to explain you with, let's say, explanation enabled to take away your subjectivity, enabled to make the interpretation from the normative requirements with some guidance text in part 2. That is the theory. Unfortunately, it's not always so easy as it sounds, because often in part number 1, the normative section, they will command you, you shall do something. Whereas in part 2, the informative section is not necessarily will help you to explain how can you achieve whatever the requirement was asking you, you shall achieve it. So the edition today, edition 2, is the consolidated version 2017, which will actually include the complete framework. And one of the framework that we will explain today will be that life cycle. It will also define you different systems on how you can configure them with system architectures, with hardware fault tolerance, etc. It will have dedicated requirements for hardware as well as for software. It will define compliance requirements on how you will plan all those activities, on top of which how you will have to manage them. It will give you technical requirements, it will give you documentation, and also there is a specific requirement towards competency that I will also explain you later towards the end here on this webinar. The informative section, part two, is about double size, because here looking at 84 pages, here we're looking at 204 pages. But unfortunately, not always the items are explained the way that we as engineers would like to have it explained. So it would make our, let's say, subjectivity less. I would be exactly giving some examples on how we can achieve things. Part number three is also informative and give you additional guidance on how to do things like calculations, things like LOPA, etc. Now, unfortunately, the part number three is not as good as it should be. So it is written by the, let's say, instrumentation and system specialist, which put a lot of effort here in the normative section in that chapter 11 or close 11, which is design and engineering of your SIS. Now, it will not give you guidance in part three as an example on how to run a HAZOP or how to do a LOPA. They may refer to it, but let's say part three is there's some room for improvements on that informative section, part number three. There's a first poll question that I would like to throw into this webinar. I would like to understand from you who has access today to the current edition 2 of the 6.15.11 standard. If it is now called the IEC 6.15.11 or the ISA 6.15.11, I would like to, Gabriele, can you launch this poll for me, please?
Yes, I'm checking, but it's not in the question list.
Oh, okay. Well, then we cannot launch a poll. Anyway, I wanted to know, of course, who have access to this specific standard. I'm not sure if I can check here the polls and the relevant. No, actually, I see there is a wrong poll in that webinar. Do you see the same, Gabriele? I see here a question about safety relays, which is
Safety
not a poll
relays,
question
yes, it's not the
from me.
same.
So
Okay.
I guess whoever has prepared here the poll questions for Zoom has skipped our poll. Okay, well, if it is not on the questions, then we will move on. All right. So basically, based on my previous experience and previous polls, and also doing this training on a monthly base for mainly for TOV Ireland as a competency review, I would say the majority of engineers that come in my training classes or actually in webinars, they know about the standard, but they have no access to a digital document that they can actually use. So the question is, how can we measure that someone is competent if you don't give them access to the document that they have to be competent in? Of course, if you have to go on the IEC web store, which is the IEC.ch, which is the extension for the web store in Switzerland, you can purchase such a standard, but such documents are typically not very cheap. They are quite some, let's say, an investment for most of the engineers or most of the companies. Of course, if you would be a member of the ISA, you can view those standards online without having to buy them. You can view them, but of course you cannot copy them. There's an alternative, which is a web shop, which is in the Estonian website, which is the abbreviation EVS, so E for Echo, V for Victor, S for Sierra, dot. Now I'm trying to remember, I think it's .ee. It's the Estonian website. And you can, of course, read it in Estonian or you can go into English. And there you can also purchase the IEC 6.15.11 with a Estonian web page, or sorry, front page in the standard, which will be about 1/10 of the price or of the budget that you would spend in Switzerland. So you can buy it at a cheaper version in Estonia. Anyway, I was coming back on the life cycle itself. Here is a very brief overview. What do we try to describe as activities in such a life cycle? So here we have all the bluish colors. We call it all the normative sections. And you can see there is a whole lot about technical items in that standard. And there is also in the part one, there is some supporting parts on the technical requirements. Part two and part three, which was the section two and section three that I mentioned before, are the informative sections. It's additional guidance on top. The entire life cycle in the standard is not prescriptive, it is performance-based. From the edition 1 to the edition 2, many should statements in edition 1 became you shall do it in the edition number 2. We remain the concept the same as in edition 1. We are remaining the same life cycle, which is mainly explained over here in the blue section. The only small difference, if you really want to be detailed, let's say review between edition 2 and edition 1, is here the word software programming from edition 1 became here, if you can see my cursor hovering, became application programming in the edition number 2. Basically meaning that if you buy a safety PLC and you program that logic inside the safety PLC, edition 1 used to call this software programming. We are now calling this, according to the 6.15.11 edition 2, we call this application programming. The safety integrity levels remain the same. So yes, we still have 4 SIL levels, SIL 1, SIL 2, SIL 3, and SIL 4. The higher the SIL number, the more available it will have to be, the less it is allowed to fail. Simply speaking, a SIL 1 is allowed to fail 10 times more or be 10 times less available than the SIL 2. So between the two SIL bands or between the SIL bands, we always have this magnitude or factor 10 of availability opposite of failing potential. The factory acceptance test that everyone probably will recognize as the abbreviation as an FAT became normative in the edition 2 for a very strange reason. Edition 1 was having chapter 13, which is called factory acceptance test. It was listed in the edition 1 in the normative section, but that one chapter 13 was having between brackets informative. We never really understood why they make it informative in the edition 1, but in the edition 2 today, all the chapters in the normative section became normative as they should have been from day 1. Every reference today in the edition 2 is of course referring to the current edition of the 6.15.08, and today we are still in the edition 2. Edition 3 is nearly there, not yet. Target was 2026, 2027, somewhere in that range. We are expecting that the edition 3 of the 6.15.08 will be released. There are two fundamental concepts, which again remain the same, comparing it with the edition 1. So if any one of you listening into this webinar that had some experience with the edition 1, well, it's the same, let's say, approach that we will do in the edition number 2. The life cycle is a kind of a fundamental, let's say, approach on how we will have to handle all those activities in a systematic way, in the hope that when we can force our engineers to follow that systematic working principles, that they will follow step per step, they will document step per step, they will verify step per step. That's basically the idea behind such a life cycle. Forcing engineers to do something in a systematic approach and giving him some guidance will hopefully lead into potentially engineers will have less room for making some mistakes. It's a probabilistic performance-based design. Therefore, the standard is called performance-based. Since we are using failure rate enabled to express our availability or unavailability on our safety loops. And of course, in safety business, we're always caring about those danger failures, which is opposite with production and process people. Those are typically focusing on maintaining their production, whereas safety engineers are typically focusing on, can we still achieve safety despite having one or more internal danger failures in our safety loops. Let's see the picture of the life cycle, which majority of you hopefully have seen this already. And of course, the life cycle itself, it starts here from the very first task in any project, always to identify your hazards. Once we start to understand our hazards, we need to analyze the hazard to understand what are the potential consequences, what are the potential frequencies that this hazard can occur. Because once we understand the consequences, and of course the frequencies are always very difficult to judge how frequent something will happen if it potentially never have happened before. So how do we have to judge this? There are also kind of items that we could highlight. Mainly we do that in a training course. We are skipping that mainly in a webinar, but very briefly, that is where the estimate of frequency will be the first challenge in most of the projects. And then we need to check with the end user or the operating companies what is acceptable for those plant managers, for this corporate management, etc. And based on whatever consequence is accepted in terms of frequency for them, that will be our target driven towards how much risk reduction potentially or how much frequency reduction potentially we will have to go. Of course, we're not only working in frequency reduction, we will also try to see other means of risk reduction, which is here shown here in this greenish color, which is here still in our analysis. And the analysis is done here based on our second block, which is called our layer of protection analysis. So once we have done the study, once we have identified what hazards do we have, we then brainstorm in analysis what are the potential consequences, potentially what could be the potential frequencies. Once we have done all that, we will then take a calibrated risk matrix, or let's say a giving risk, tolerable risk for us. Once we have that risk matrix in front of us, then we will search based on the consequences, based on the frequencies that we estimated in our team, and based on what is acceptable by the corporate management. That gap will be your frequency that we try to reduce later on here in our safety loops. And the safety loops, when there is a need for an additional safety loop, that is what we will actually have to describe in your safety requirement specification. By the way, we have a dedicated safety requirement specification webinar also, because today we have 29 items per safety loops that shall describe and shall include the entire safety loop description, and the entire safety requirement specification has also been given by GMI in their latest publication, which is the GMI SIL manual. And I'm referring to the edition 5, which is also shown later on here in this webinar. So bottom line, once we came up with an additional request to build an additional safety interlocking system or safety interlock, before we start to build it, we need to do this stage 1, which is an assessment. That's a senior independent competent assessment from someone not involved in a design team to make a judgment. Whatever the description is required will be sufficient to reduce that potential risk that came up here in the phase 1 study. Once we start to build, design and engineer our safety instrumented system, the majority of all the input text is coming out of this chapter 11. Chapter 12 here, or the number 12 referring in that box 4, which we call phase number 4, is the application programming of your safety PLC. And chapter 13, which I already mentioned, is your FAT. Other means of risk reduction means it's not a safety instrumented system. It can be, for instance, locking a building that no one can go in, as an example. Well, those other means of risk reductions together with a safety instrumented system, together we will install and commission it on site. Before we ship our SIS system or our, let's say, solution that was designed and engineered as part of the safety instrumented system with the manufacturer, we will do an FAT. And before we ship it, we require in the new standard here a functional safety assessment stage 2, again by a senior independent person not involved in the design. Now we are on site, we do installation commissioning. Before we're going to start up, we will do the validation. And the validation is typically known in the industry as the site acceptance test. Once we have done the site acceptance test, and before we allow the production people to start up the production or to line up the hazards in their production facilities, we need to do a stage 3. And the stage 3 is again by a senior competent person not involved in design. And typically we call that the PSSRs, which stands for the Pre-Startup Safety Review, which is kind of a checklist to make sure that the installation is totally checked, is totally ready, the people are trained, the procedures are ready, etc., etc. And then it's up to the operator and maintenance people from the operating companies or the end users, which is here called Chapter 6. And here we want to do a periodic assessment, which is a stage 4. And the stage 4 is now again by a senior competent person not involved in the same operation and the same maintenance of the same sys. Last but not least, we have the modification. And again, we will talk about the MOCs here. We will talk about the approval cycle. We need to do a assessment, which is stage 5. We want to do the stage 5 before and also after the modification is finished, leading us into the final stage or the final phase here, phase number 8, which is called the decommissioning. All this must be managed. All this must be assessed. All this must be audited. All of that must be nicely planned and nicely documented and structured. And of course, also every phase before we continue needs to be verified. That is the life cycle in a record tempo in 10 minutes explained on how you have to handle your projects. Summary, it will deal with activities and responsibilities in a systematically way. It needs to identify the competencies required per phase, who can do what, and because of their competence, they are the people or the engineers which are identified to handle those type of activities. Of course, there needs to be documented requirements. We need to know what do we try to achieve here. And it will also address the life cycle, which I just mentioned or showed you very briefly, the functional safety management, the verification, the validation, the functional safety assessment, and the audits. The last bullet, it's all to do with the qualities. How can we prove and check and maintain the qualities of those activities for which we are responsible slash accountable? And clear, we will have a different life cycle for an end user versus a system integrator versus an engineering contractor. As we don't have the poll, let me give you the poll here in a verbal way.
No, we have it. We have it. I made it fix.
You have it in the meantime?
So.
All right, good.
I think you can see it now.
Good, thank you. So, addition to lifecycle activities and requirements are changing per SIL level. That is the first answer that you could think of. B, it is irrelevant of the SIL level, which means it is neutral. The lifecycle is applicable for every SIL. Then C, it is not applicable for SISs built before 2016. D, none of the above. So what is your gut feeling of A, B, C, or D? And same as during our exams on the competency review for TFV Ireland, only one answer is the most complete and the most correct. So if you believe that none of them, A, B, C, is correct, well, then you have to select D, or you can select either individual A or B or C. Okay, we have 65% of our participants have clicked. In the meantime, 74, 73. So we're nearly there. We need 2 more clicks. So whoever has not clicked, give us one of your guesses. You cannot lose any face or money or your job, because we will not tell your boss if you clicked the wrong one, because we are very polite here. All right. Can I have one more click? Come on. There we go. All right. I think we can launch the poll. So we end the poll here and you can share the results, Gabriele, if you want. All right. So I still don't know why we still have the majority thinking the life cycle is changing per SIL level. And I have no idea where this illusion or this misunderstanding or this confusing is coming from, because unfortunately, this is not true. The life cycle is applicable no matter what SIL level we have. Maybe there is some misunderstanding coming from the 61508, where there is a slightly, let's say, indication on SIL level, but that's purely to do with the assessments in dependencies. But that's not applicable for the 61511. We don't care what SIL level you're trying to approach, if you're approaching a SIL 1 or a SIL 2 or a SIL 3. So it is irrelevant of the SIL level, which is here only 22% of our audience, which I would say correct. That is irrelevant of the SIL level. And it is not applicable for sys builds before February 2016 with a pinch of salt. This is also not correct because we need to do a current edition too. If you are looking into your current installation, and example, the installation has been built before the edition 2 has been released, of course, we need to do a gap analysis. We need to see where are the targets, where do we have to be, and based on that so-called grandfather clause, we need to make a decision what additional measurements potentially do we have to foresee in able to protect us from our current hazards, which are in the older installations today that was built before the 2016. So the life cycle, the only correct answer would have been here B. It is irrelevant of the sill level, and even the sill level that is for the older systems, we still have to investigate and we still have to do our gap analysis. In a summary, we have the analysis phases, and the analysis phases is the phase 1, 2, and 3, which we call like the start of any project. We have then the realization phases. That is here where we have to design and engineer our system. We have to install commissioning and prove them again with a validation that the systems are ready, the people are ready, the procedures are ready, etc. And then we have finally the operator and maintenance, which is typically the longest duration of any project. You can imagine any engineer that has been involved in doing some, let's say, design and engineering themselves was maybe months. It was not years typically. But when you go to the operator and maintenance, when I go to some current existing customers, some of those customers are running those facilities for 50, 60, 70. I even have been on a plant that was more than 100 years old. It even survived the world wars and it was still there. That means that those type of plants are existing for many, 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 many years. That means certainly here we have a very long period and we have rotation of people. We have people going in retirement. We have people quitting the job. We have shift changes. So how do we maintain all that culture going with all those different people? Whereas here, if you're doing a HAZOP and you are involved in a HAZOP team, hopefully you will not rotate your people every single meeting. You will have the same consistency of people during that. So that is the challenges that we see here already in that life cycle period. And of course, everything must be managed, assessed, audited, documented, planned, and also needs to be verified. That's the overall, let's say, definition that we show you here in bullet number 4. I'm going to give you a wrap up on all those phases because I still want to handle your registered questions during your registration. So, what is here the first 3 phases on the analysis, which is phase 1, 2, and 3? It always starts that we are requiring that people will identify the process hazards. And also you are required mandatory as a functional safety management requirement. You also mandatory obliged to define your risk that goes along with your hazard. For instance, you cannot do like they have done in the old days with the incident in the industry called Bhopal in India was based on a US, let's say, end user that did a cut, copy, paste from an existing facility in US and they planned it into India without doing a new risk analysis because there they had a complete different risk criteria around that facility. Well, that is certainly not that we would like to repeat in the future. That means that since the edition 1 came out in 2004, it's mandatory required to prove that you have done a hazard identification practice, a hazard analysis, and also a risk analysis. What is new by the edition 2? Well, new, it's already 9 years old today, so it's still called new, but it is based on the latest edition. You shall carry out a security risk assessment on your industrial automation control system, which we call the IACS. Second bullet, you are required to allocate safety function to protection layers. That is what you typically will do here in phase number 2, which is so-called LOPA, which stands for layer of protection analysis. And when you come out of that exercise in your LOPA that your tolerable risk cannot be achieved, that means the tolerable criteria that is typically given by the end user or operating company, you need to come up with additional protection. And the additional protection can either be assist or can either be other means of risk reduction. But if it will be assist, you will have to define that in your safety requirement specification. And if you plan to use a programmable logic solver by software programming, we also have solid state programmable system by wiring programming. You wire your logic with solid state. Either of them needs to be specified in a definition which is called the application program safety requirement specification. And before we're going to start to build the system, as we mentioned, a functional safety assessment stage 1, which is a normative requirement, shall be carried out by a senior independent competent person not involved in any of those phases 1, 2, or 3. The next step was your realization phase, which is 4 and 5. Here we're going to go in our design and engineering, which is the majority of text input in your normative section, part 1 of the 6.15.11. And if you go into chapter or clause 11, it's called design and engineering of your safety instrumented system. And of course, there is a lot of technical details in there that you need to understand and able to build the correct architecture for the dedicated SIL that you try to achieve. So you will be driven into a certain system architecture, which will be based on either this road 1H or road 2H. And the road to H can be here in this case either prior use for the SIG 1511 for the end users or proved in use for the manufacturer, which is the road to H coming from the 6.1508. It will specify techniques and quantitative analysis for your SIL levels. You need to go through your factory acceptance test in able to prove that you are checking and testing the functionality of whatever system you have been building as a functionality based on your safety requirement specification. And that needs to be followed here in that yellowish block here in the middle. You see there a small stage 2. Well, stage 2 is again a normative requirement from the IEC 6.15.11 standard that needs to be carried out again by the senior independent competent person. Needs to make an expert judgment, and that expert judgment is not related to any work activities involved in that phase 1, 2, or 3, or 4, because you need to be independent from the design. Design and developments of other means of risk reduction, that is what this greenish block is showing you over here. And then you go on site, you do installation, commissioning, and final validation, which is called your site acceptance test. Again, the site acceptance test needs to be followed with a functional safety assessment, which is this famous stage 3. And stage 3 was known in standard edition 1. You need to do the assessment before you introduce the hazardous products in your production facilities. And finally, we go to the operator and maintenance phases 6, 7, and 8, which again, that's probably 10, 20, 30, up to maybe 100 years or even more. So it's for a very long period. You try to operate and you try to maintain your systems safely. The focus on the 6.15.11 edition 2 is mainly based on forcing the end users or advising the end users to collect field data from their own installation with their own experience, with their own proof test evidence that they have done, not from a database coming from a collection of data from other fields, other vendors, other generic data. That is not the intention of the 6.15.11. So basically, it's quality field data that we need to try to collect through operation and mechanical integrity programs, enabled to prove the performance of our safety instrumented systems if I would be here now, the end user talking. It also requires that you will prove your proof test effectiveness and consistencies throughout your maintenance phases. In other words, if you have all this rotation of people, you have all these different people coming in with all the same job profile, how can you prove how consistent those different engineers are carrying out the same proof test on your safety systems? We need to do a functional safety assessment periodic repeating. So it will be periodically. It's always returning, coming back, which is a normative requirement, again, coming from the 6.15.11 edition to today. And that stage 4 is done by a senior independent competent person, but now the requirement is to be independent from the same operations and the same maintenance of the same sys. Modifications will be as part of your MOC or management of change procedures. Again, the assessment stage 5 is a normative requirement, and the requirement is before you make the modification and after you finish the modification. So basically, you will carry out that assessment twice, and that needs to be done by the same senior or again by a senior competent person, again independent from the same operation and the same maintenance on the same sys. And the decommissioning, which is the last phase 8, will basically follow the same as the other phase modification. Summary, the general phases 9, 10, and 11, 11 and 10 are here shown on the left-hand side. 10 is known as our function safety management requirement in the standard, whereas 11 is known as the structured planning and the documentation. And then here, block number 9 or phase number 9, that is our verification that is valid for every single phase on the life cycle. So function safety is about quality and reducing potential human failures carrying out some activities in that life cycle. All the safety activities needs to be planned. So we need to exactly plan when we will do all those activities in a structured way. When they are planned, they will be referenced in a document. That means the document becomes our requirements. And of course, they will be planned in terms of a activity planning. When will we carry out what phase in the life cycle? Every safety related activity shall be verified before we are carrying out to the next phase. That is basically the backbone of a life cycle called here the 6.15.11. All right, we have the second last poll question here for today. Who of you have followed a competency review program on that dedicated standard called 6.15.11? And maybe some of you followed the edition 1 Lifecycle competency review course and still have a valid certificate today. That would be of interest for me as an indicator to understand how much or how many engineers still out there that needs to have either an updated version of the standard competency review program, or they have done their review themselves and they still carry a certificate. B is 6.15.11 edition 1, but your certificate is currently expired, which is potentially. And of course, if it's expired for a long period, you may ask yourself the question, am I still competent to carry out the activities for which I've been made accountable or responsible based on the edition, current edition of today? And C is edition 2, has been trained and you have a valid certificate, or D, none of the above. Well, my expectations are actually correct. We still need a few more clicks. Okay, it's just a good indicator for us to see what is going on in the industry. Of course, it goes without saying, you logging in here to this webinar, although I see a few names that I do recognize from previous courses, even from very recent courses. Majority who is here online is most likely never been trained before or doesn't have any, let's say, competency review scheme that you have been following. That's why you are most likely interested in understanding what is it all about. And that is also why we do this poll question. All right, in the meantime, here are the results. None of the above is the majority. So, well, it's a good start that you are listening into a webinar. So at least you have a little bit of what is the idea behind the life cycle. We see also that, there were people trained on the edition 1, which is here this 12%. Saying you were trained on edition 1 and still have a valid certificate today. Well, edition 1 is obsolete since 2016-17, so it is nearly 10 years. And by memory, certification are classically valid for 5 year after 5 years you have to renew. So potentially you have renewed it. It may be expiring next year, which is 2026, potentially. So some of them have an expired certificate, and that is for us a indicator to see that, enabled to prove to the outside world or to your management or whatever that you still have a valid certificate, or you need to prove that you are with the current edition still competent. There are, of course, some competency review schemes available on the market. What is here my summary, my main takeaway that I want to give you? It's not all about that famous SIL number and PFD, because that is often what we've seen in the past. People are thinking they are doing some safety engineering, and they're blindly focusing on that SIL number and those PFD numbers. And of course, PFD numbers is purely an estimate of an availability. And that's certainly not the purpose of the 61511. The main purpose still today for me is to guidance giving to the engineers, enabled to carry out the activities. And in the hope, when they will follow that type of guidance, which is called the good engineering practice from the 61511, they will make less mistakes themselves. They will learn, hopefully, from mistakes that were done before that period. And that lesson has been giving guidance in a text which is called the IEC 61511. So the Function Safety Lifecycle provides you a systematic approach enabled to achieve, hopefully, safety in the process industry. And the process industry, by the edition 2, the following applications are covered. It's the oil and gas, traditionally from the edition 1. It's also the chemical and petrochemical industry, like the edition 1 was covering. What was new by edition 2 in 2016-17, they added the pharmaceutical business in there, or applications, and also the food and beverage. Function safety is not automatically achieved. It's not like, oh, I bought a SIL3 relay from GMI and therefore I don't have to do anything. Everything is safe. That's not how it works. You're building your integrity in your system, but you still will have to do something. You still will have to prove that things are working the way they are supposed to work. It's more a culture that sits between your two ears. So you cannot buy it. You only have to earn it by trying to practice it, by trying to understand it, by trying to perform. So it is a mindset that needs to be learned and trained. It needs to be applied on your daily activities. And of course, it will need to be maintained with evidence. You need to prove how you will maintain that. Excuse me, enable to become a competent functional safety engineer. We as GMI, with a team of engineers, we are helping in the life cycle to support our end users or engineering teams that are doing those type of activities, which I will not list here. We also additionally can support you with life cycle support for the 62443. One of the main tasks of myself in the team is still to provide the functional safety engineer training, and we just finished last week our last training for 2025. I was just thinking which year we just finished, which has been an extreme busy year. We have so many training courses over the year and so many engineers trained again this year that I'm asking myself the question, is this continuing for the rest of my, let's say, activity that I'm doing as a trainer for TLV Rhineland? So we mainly are training the engineers on the SIS competency review program from Rhineland. We also have the two cybersecurity. There's a third one not shown here, which is the combined fundamental and security risk assessment. We also, of course, do customized in-house training. I have some at the beginning of next year in Eastern Europe, a customized training again, based on the request from the client. So we customize it towards whatever experience that specific company wants to have. And of course, there are some more free GMI webinars to follow. That's the best book you can have, because first of all, it is a book that GMI is giving out in the industry, and there are more than 50,000 copies worldwide. Go for the 5th edition, because in the latest 5th edition, which is new by 2025, beginning of this year, there is an additional chapter in there called chapter 10, which is the chapter to read on functional safety management, Why? Because I was the author of this chapter 10, and I'm just bragging now. But chapter 10 is Function Safety Management. Chapter 7 is SIG 1511, which has also been revised in edition 5. And chapter 8 is the Safety Requirement Specification. Only those 3 chapters I have been putting some work in. The other chapters were written by my colleagues, so they, of course, they are equivalent in quality to read. But the chapter 10 is a new one on functional safety management. Before we will close, I want to share with you the Q&A, which is also shown in here. Okay, here we go. So I'm just trying to, oops, I got too many screens open and I have no space anymore to start the screen. Let me stop sharing this again and first move my screen into a corner that I can actually operate it. Sorry for that. Okay, I'm nearly there. One click, share this file again. Now I can start it, and now you should see the first question that came in during the registration. And the question that this engineer was asking was, under the IEC 61511, if demand frequency increases, so I assume that engineer means a demand from the hazard. Potentially, that is the question, because it's not very clear, but let's just assume it is the hazard demand frequency increases. And the proof test interval must be extended, which is a classical story in the process industry. Production people wants to wait as long as possible to do something, enable to avoid that their production needs to go to a stop, let's say, position to prove that the system is still working correctly. What is the minimum set of life cycle elements you must revalidate to justify keeping the original SIL? This goes very well in line with the complete explanation of the life cycle. That is why I thought I need to take this question serious. I need to try to put some effort in how to answer this. So the first step that you will have to redo, in my opinion, is one, you have to confirm that the change in your hazard demand rate does not invalidate the original risk assumptions. Because remember, in the risk assumptions initially on that project, the team brainstormed and estimated a specific demand for that hazard, which came to a number. And based on that number later on, someone has built a safety system. If for some reason now we are proving that the hazard of the demand is starting to increase, that means the assumption in the older days may have been wrong or was wrong. Means, what do we have to do? That is the first step. Second, based on that new demand rate and based on the required risk reduction, maybe we need to think about, do we have a different mode of operation? I give you an example. Potentially in the initial phase of the project, the brainstorming specialist team was thinking that a demand on the hazard on the process will not happen more than once every 3 years. And by evidence now, the demand rate is now every 8 months. That means the demand is happening more than once per year. That means you're moving from a low demand mode in a high demand mode, and we want to investigate, first of all, why do we have more demands? Maybe we are not handling the product as the brainstorming specialist team was thinking. Maybe we are handling with less caution. Maybe that's the reason why we have more frequent demands. That is one potential reason. Second reason could be that maybe your material that you're using in that safety loop is maybe not as reliable or trustable as that brainstorming specialist team was believing that they would have to protect their hazards from happening. We also will have to look in the proof test interval assumptions, because initially there was an assumption, how frequent will we go and test that specific system? We certainly will have to do a re-estimate or a re-verification of the SIL integrity level of that specific, let's say, safety function based on the updated demand frequency of that loop and based on the required delayed proof test interval. If our mission time can still be achieved on that specific performance for that specific safety loop. The proof test strategy and the coverage factor is something that needs to be confirmed again to check how effectiveness was the proof test previously on those loop? Because maybe because the proof test previously was not so effective, was not so good enough, was maybe one of the reasons why now we have a more frequent demand on that specific safety loop. It was probably not the hazard demand, it was a demand happening on that safety loop because of whatever mistake or whatever, let's say, hidden failure was still in that specific safety loop. Operation and maintenance procedures needs to be continually verified again to check the capability. Do we have enough information for our maintenance and operators to manage and to reveal those danger failures in their system? And of course, it goes without saying that all of this will need to be reassessed by an expert judgment, someone that is not involved in the same operation and the same maintenance of that same SIS system. Second question, how should the periodic inspection be carried out? What are the requirements for competency of inspection personnel? Again, that fits perfectly, I think, in the life cycle discussion. Well, how should periodic inspection be carried out? Well, simply speaking, follow your procedures. Of course, if your procedures are not detailed, complete, or not clear enough, well, then the engineers will not be able to follow the right procedures to handle those periodic inspections. Based on defined inspection intervals, very clearly, if someone defines in the beginning of the project that we will test the loop every 1 year as an example, we need to check that those every 1 years will be maintained and will be followed. What we do not want to have, we do not want to delay this by whatever excuse. We need to check whatever was predefined as an inspection proof test interval, that we will actually prove that we have followed that. So what are the acceptance criteria in there? Include as found as left plus the recording and evidence. It's always the evidence that we need to check during that periodic inspection. And the results shall be documented, shall be reviewed and acted upon. Well, that is the evidence that we will need to see in your kind of verification report. Again, that's also part of an evidence for the quality measurements, which is the function safety management under the SIS performance. The competency, well, competency have three measurements for us in the 6.15.11. Competency is measured on formal training, experience, and knowledge. That means the personnel itself shall be competent for the task which they are responsible / accountable for. The competency shall cover, of course, the operation. Also, the maintenance people needs to know exactly how they can find their failure modes. We need to help them with that. There is something called the functional safety manual in the 6.15.11 for that. And also the inspection methods, we need to help them enable how they can inspect those specific functionalities on those loop. Competency shall be demonstratable, shall also be maintained. You need to prove how you check the competency of those, let's say, engineers, if it is now operation or maintenance engineers. And of course, the independency required were specified, example, independency for those expert judgments on assessments and on audits. The last question that I also was giving during the registration, learn more about how to use the life cycle phases in a systematic way. Well, that is actually repeating what we have just been showing you in the life cycle. So follow the defined life cycle sequence from top to bottom. So don't cherry pick which one you like to do today. You need to always go to the complete life cycle and able to follow it in a structured way. Clearly define the roles and responsibilities and deliverables. Very important, deliverables per life cycle phase. How can we prove evidence that we deliver the activity as required? Because that deliverable, most likely your verification report will be needed by the expert judgment, independent expert, senior expert assessors. Use the safety requirement specification or the SRS as the central reference across all the phases. So once your projects are built, maintain a very up-to-date, as-built, clear, and also complete safety requirement specification document. Apply the verification at every single phase. Perform the function safety assessment as required by the standard, and manage changes through let's say, a good MOC, Management of Change Procedure, like is a culture in the process safety industry. Summary, which is my last word, the life cycle is a structured management framework, not a checklist. It must be planned. It must be carried out or executed. It needs to be always verified, and it needs to be assessed. There are some more webinars coming. Of course, we are the end of 2025. 2026 yesterday evening was not been announced, although Gabriele and myself, we already agreed on like 6 or 7 dates for functional safety next year to make some webinars again. So there will be some schedule coming up. That's here the link which you can open, and you can go into the website of GMI with the live webinars. Every webinar, as Gabriela was mentioning, will or is recorded on the YouTube channel from GMI. And there are about, yesterday I noticed here, there are 157 videos already on that channel. So if you're getting bored for Christmas dinner, or you have a fight with your wife, you can always spend your time watching some recorded videos. Of course, now I'm totally joking. That's the teaser for the videos. It's not only functional safety, of course, because GMI is more than just functional safety. They also have all the fundamentals on EX. They have the different languages available for certain webinars, etc., etc. That's the last poll. That's my last slide for this year on 2025. So you can imagine I feel a bit of relief that I have done another webinar. I would say thank you for all the attendees. I was quite surprised, to be honest, and frankly with you, that we kept the number of attendees towards the last second of the webinar. Typically, we keep on losing them during the Q&A session, but today, maybe you all being end of the week or end of your working career on 2025, so you want to listen to a webinar. So it only gives us the pleasure to say thank you again. Thank you, Gabriele.
Thank you, Tino.
And now we're getting lots of clicks. Well, still a few people that haven't clicked yet. Let's make a test. Can someone click? We have done a poor presentation, because we never get anything poor on all the presentation we have done. Because the one that clicked poor, right? You can tell me why you think it was not good for you. Maybe you were wrong in the wrong webinar, or maybe you didn't like what you hear. No? Okay. So my wish for 2025 is not been solved. All right. Well, that's it. And the poll. We will share the poll over here. Oh, let me just turn this one down. All right. Oh, failed to share the poll. Another poll has started or shared. Okay, maybe you are sharing it. Sorry. Okay, Gabriele, thank you. Everyone,
Thank you.
have a very lovely Christmas, hopefully with friends and family. And also have a very happy new year coming up. And next year, let's try to search a topic which has not been handled yet on the functional safety, to keep it interested for you to come back. All right. Thank you, Gabriele.
Thank you, Tino. Have a
All
nice
the
day.
best.
Bye.
Bye-bye.